Imagine this. Everything you see around you, your home, your family, the Earth, the stars, galaxies, even the very laws of physics, might not be as permanent as they feel. The entire universe could be perched precariously in a temporary state of stability, like a ball resting on the side of a hill instead of at the bottom of the valley. And if that's true, then one day, without warning, everything could unravel in the blink of an eye. This is not science fiction. This is the terrifyingly real possibility of what physicists call a false vacuum. To understand this, let's step back. Our universe is governed by quantum fields, invisible entities that permeate all of space and time. Every particle, every force, every interaction emerges from these fields. One of the most important of these is the Higgs field, discovered indirectly in 2012 through the detection of the Higgs boson at CERN's Large Hadron Collider. The Higgs field is what gives particles their mass, and without it, matter as we know it wouldn't exist. But here's the unsettling part. Calculations based on the mass of the Higgs boson suggest that our universe may not be sitting in the true lowest energy state of reality. Instead, we could be stuck in a metastable state, a temporary condition, a false vacuum. Picture a landscape of hills and valleys. The true vacuum is like the deepest valley, the most stable state. A ball resting there will never roll away. But if the ball is sitting on a smaller dip higher up the hill, it seems stable for now, until the tiniest disturbance nudges it, and suddenly it rolls down into the deeper valley. That's us. Our universe might just be that ball, resting in a precarious dip, giving us the illusion of stability while an abyss of lower energy lies just beneath us. And if the universe ever tunnels from this false vacuum to the true vacuum, the consequences would be unimaginable. But what does tunneling mean? Quantum mechanics tells us that particles don't always behave like solid billiard balls. Instead, they act like waves, and sometimes they can slip through barriers that should be impossible to cross. This process, called quantum tunneling, happens at the subatomic scale all the time. Your computer chips, for example, rely on this effect. Now, imagine that same process, but not just with a single particle. Imagine the entire fabric of reality tunneling into a more stable state. If the Higgs field were to suddenly shift, the constants of nature could change instantly. Forces like electromagnetism and gravity would no longer behave the way they do. Atoms wouldn't hold together, stars wouldn't shine, and chemistry itself would break down. In essence, everything, life, matter, even the structure of space-time, would be obliterated in an instant. Here's the part that makes it even more chilling. If a vacuum collapse were to happen, it wouldn't be something we could see coming. It would start in one location, maybe far away, maybe near us, and expand outward at the speed of light. A bubble of true vacuum, rewriting the laws of physics as it goes, consuming everything in its path. You wouldn't feel pain. You wouldn't even know it happened. One moment, the world would be here. The next, it would be gone. So, is this a doomsday scenario that should keep us awake at night? The answer is complicated. On one hand, the math does suggest that our universe might indeed be in a false vacuum. The mass of the Higgs boson, about 125 giga-electronvolts, sits uncomfortably close to the boundary between stability and instability. Physicists like Joseph Likon and others have pointed out that this value makes it possible, maybe even likely, that the universe is metastable. In other words, reality is like a cosmic Jenga tower, balanced but not permanent. But, on the other hand, the timescales involved are almost incomprehensible. Even if vacuum decay is inevitable, estimates suggest it wouldn't happen for trillions upon trillions of years. In fact, the heat death of the universe, the slow fading away of all energy and light, might happen long before vacuum decay does. So, in a practical sense, we're probably safe for the foreseeable future. Probably. Still, the mere possibility opens up unsettling questions. If the universe is temporary, then what does that mean for our place in it? Humanity has always thought of existence as something solid, something real. We build civilizations, write books, fall in love, and dream of the future. But if reality itself can vanish without warning, what does forever even mean? It forces us to confront our fragility at the most fundamental level, not just as mortal beings, but as patterns of matter in a universe that itself may be mortal. And there's another twist. Some physicists wonder whether the collapse of a false vacuum might not just be the end, but also a beginning. If a true vacuum bubble expanded and consumed the universe, could it give birth to new laws of physics, a new kind of reality, maybe even a new universe entirely? From the outside, this sounds like annihilation, but from the inside, perhaps it would be creation. A rebirth where the universe rewrites its own rules. Of course, we'd never know. Whatever new physics emerges would be so alien that our atoms, our biology, our very concept of thought could not exist in it. To us, it's indistinguishable from oblivion. It's worth pausing to reflect on the strange beauty of this idea. The very equations that describe the Higgs field, written down by scientists with chalk on a blackboard, contain within them the possibility of both our existence and our destruction. In a sense, the universe has always carried within it the seed of its own undoing, and yet, for 13.8 billion years, that seed hasn't sprouted. Stars have formed, galaxies have collided, life has arisen, and humans have begun to wonder about the fate of it all. We exist in the shadow of cosmic impermanence, and yet we exist. That paradox is both terrifying and awe-inspiring. But let's bring this closer to home. Imagine you're sitting with friends, laughing, sharing a meal, or you're walking alone at night, looking at the stars. At that moment, a bubble of true vacuum could already be racing toward us from some distant corner of the universe, and we would never know. There is no warning, no siren, no escape plan. If that sounds horrifying, it should, but it should also make you pause. Because it means that every second of life is precious. Every smile, every breath, every dream. The universe doesn't guarantee us eternity. All it gives us is now. So, could the universe be in a temporary state that might collapse at any moment? The answer is yes. The Higgs boson hints at that possibility, and quantum physics makes it real. But whether that collapse happens tomorrow, or a trillion years from now, or never at all, is something no one can say. What we do know is that life goes on, fragile but luminous, in a cosmos that may itself be fragile. And maybe the real lesson of the false vacuum is not to live in fear of sudden annihilation, but to marvel at the unlikely fact that we're here at all, living, thinking, and asking these questions in a universe that allows it. Because one day, without notice, everything could vanish. But today, right now, we are here. And that, in itself, is nothing short of miraculous.